In this question, it is given that in the expansion of this px plus 3 to the power of 5 minus x cubed plus p upon x to the power of 4, the coefficient of x to the power of 4 is 216. So this basically means that 216 x to the power of 4. We need to find the positive constant p. So if we look closely at the expansion given, the first thing that we can see that there is a negative sign over here. Rather, it's not, these two are not being multiplied. Instead, there's a negative sign over here. So what this means is when we expand this term, we'll get x to the power of 4. A rather certain x to the power of 4, which we don't know. Let's just call that a. And when we expand this side, we'll also get an x to the power of 4 term, and which will also have an unknown coefficient. We can call that b. When we do get these two values, what we just need to do is we need to subtract those two values, and we'll get 216 x to the power of 4x as given in the question. I hope that makes sense, and let's just expand these terms first. So let's write this down as px plus 3 to the power of 5 minus x cubed plus p upon x to the power of 4. We know that this side will give us ax to the power of 4, and this side will give us bx to the power of 4. The equation that we'll have will be ax to the power of 4 minus bx to the power of 4 equals to 216x to the power of 4. Let's expand this side first. So this is px plus 3 to the power of 5. Now we can assume that for this part, the r value will be same as the n value. To make it even more hit the sweet spot, we can also say that we can rewrite this as 3 plus p x to the power of 5, and now since the unknown x is in the b term, the r will be equals to the n value. But just to be on the safer side, let's just solve for r and see if it's r equals to 1 or not. So this will be 5 CR, because we are assuming we don't know the value of r. 5 CR BR A 5 minus r, which will be equals to ax to the power of 4. We need to isolate the unknown x values. So this will give us x 5 minus r equals to x to the power of 4. We can cancel out the bases to the rules of indices. So this is 5 minus r equals to 4, or r equals to 5 minus 4, and r equals to 1, which we said at the start, but let's just pretend we did not know all that. For the second, to expand this, we'll have 5c1 3 to the power of 1 px to the power of 5 minus 1, which is 4, equals to ax to the power of 4. 5c1 is just 5, this is 3, this is p4x4 equals to ax to the power 4, and our final ax4 is equals to 5 to the 15 p4x4. For the second part, it's x cubed plus p upon x to the power 4, and this is rather a tricky part. we know that the unknown x is in the a term as well as in the b term in the denominator. So the r value is unknown and we need to find the r value. We cannot say over here that r is equals to n because it's not true. Either r is not equals to n, we need to find the value of r. So a general expansion of this will be 4c1 b will be p upon x. Sorry, we don't know the value of r, so this will be 4cr p upon x to the power of r and a, which is x cubed 4 minus r. This will be equals to b x to the power of 4. We need to isolate the unknown x values. So again, we'll have x 3 4s are 12 minus 3r upon x to the power of r equals to x to the power of 4. Let's take this in the numerator. So this will be x 12 minus 3r minus r equals to x to the power of 4, x 12 minus 4r equals to x to the power of 4. The basis cancels out. We'll be left with 12 minus 4r equals to 4. 4r equals to 12 minus 4. 4r equals to 8 and r equals to 2. So let's do the expansion. This will be 4c2 b2 and x cubed will be 4 minus 2 is squared. This will be equals to bx to the power of 4. 4c2 is just 6. b squared upon x squared equals to x to the power of 6 equals to bx4. X squared cancels x to the power of 4 and our final b value will be x to the power of 4 equals to 6 b squared x to the power of 4. Now let's go back to this equation that we made. So we have the a value and the b value. Let's just solve for this. So ax to the power of 4 minus bx to the power of 4 equals to 216x to the power of 4. A is 15, p4, x4, 15, p4, x4 minus b is 6p square x4. It's 6p square x4 equals to 216x4. Let's sector out the x4 so that we can clean this up. So this will be x4 15p4 minus 6p squared equals to 216x4. x4 cancels out. We'll be left with 15p4 minus 6p square minus 216 equals to 0. Let's divide both sides by 3. We'll be left with 5, 3 5 15, 5p4 minus 2p square and minus 372. Let me just check. Yes, it's coming out to be 216. This will be equals to 0. Now, if you look at this, we have p square and p to the power 4, which is basically a disguised quadratic. If you are if you are smart enough, if you are brave enough, you can solve this as a disguised quadratic, but we'll take a smarter approach and we'll introduce a substitution. So let's just say that this is a disguised quadratic, and let's put p square equals 2a as a substitution. So this will become 5p4 minus, sorry, 5a square minus 2a minus 72 equals to 0. Now this is more legible for us. Looking at the factors, I believe we can have 572 is 216, I think. 5 times 70 is, no, it's 360. So what factors can we get for 360? I think minus 20 plus 18. Yes, because it's giving us minus 2a. So the factors are minus 20a plus 18a minus 72 equals to 0. 5a is a minus 4 plus 18, a minus 4 equals to 0. 5a plus 18, a minus 4 equals to 0. 5a plus 18 equals to 0, a equals to minus 18 upon 5, or a minus 4 equals to 0 and a equals to 4. Don't make the mistake of putting this as your final answer, because again and again we made a substitution. So we need to solve for b, not a. Let's reintroduce the substitution. This p square equals to a, p square equals to minus 18 upon 5, p equals to plus minus under root minus 18 upon 5, and this will be rejected because this does not have any real values. On the other side, we can have p square equals to a and p square equals to 4, p equals to plus minus under root 4, p equals to plus 2, or p equals to minus 2. Now again we have two values, but if we go back to the question, we need to find the positive constant p, positive value. So again the negative will be rejected, and our final answer will be p equals to 2.